A very warm good evening to everyone. I'm Satyendra Kumar, the moderators for today's session. It's a great honor to moderate today's webinar, Commercial Drones Take Flight, Breaking Barriers, Reaching New Heights. To start with, it's really overwhelming to see some really influential names and companies from the drone industry as part of today's audience list. This really shows that commercial drone is not just a starry-eyed buzz around aerial pizza delivery, but a lot more. Today on the esteemed panel for discussion, we have our guest speaker, Mr. Chris Fleming, CEO at Cyberhawk. I'm sure he needs no introduction. Chris is recognized as a pioneer in the UAV inspection industry and has spent his last 20 years working around the globe as an offshore inspection engineer for global marine and subsea engineering companies. Also on today's panel is Mr. Gaurav Shukla, research analyst and drone enthusiast who has authored multiple industry reports and has been widely acknowledged by industry opinion leaders for his incisive writing. Welcome to both of you. For the next 25 minutes, we are keen to learn from your experiences. And towards the end of the discussion, I will open the panel for any questions from the audiences. I would request the audience to kindly mute your phones or laptops for the next 20 to 25 minutes and type in your questions once we open the forum for discussion. Of course, any questions that we might not be able to answer today, we will definitely take it offline. Now, we at BS Research have been tracking the drone industry for 4 years and have realized that it is evolving beyond its military origin to become a very powerful tool. We have already seen high-powered drones countering rhino poachers in Malawi, drones delivering blood to clinics in Rwanda, have seen orchestrated drone performances in Las Vegas and drones mapping archaeological sites in Turkey. And while entertainment and media have been quickest to embrace commercial drones, industries like construction, oil and gas, energy, and agriculture are expected to drive commercial drone demand in the coming years. Now, one interesting thing that definitely comes to my mind is that since these new industries that they are coming up in the industry, they are also the mainstream consumer market that is getting a thrust. And now drones are being put to work in both commercial as well as civil government applications. And that is creating a market opportunity that is too large to ignore. Having said that, let me open this panel for discussion and invite thoughts from Mr. Gaurav Shukla. Over to you, Gaurav.
Thank you so much, Satyendra, for such a nice introduction. I would like to extend my warm welcome to the guests and esteemed speaker. Thank you so much for joining us on this lovely evening. I would like to begin today's discussion with four mega trends which BIS research has identified for commercial drone market. Well, the confluence of technologies like blockchain, artificial intelligence, and Internet of Things is every day revolutionizing the way we do our regular works. The impact of these technologies in drone industry is much more significant. Companies working in commercial drone industry are using these blockchain to solve real world problems. For instance, in May last year, a global retail corporation, Walmart, had filed for a patent to automate the process of drone parcel delivery using the blockchain. Along these lines, a Deep Arrow project is using blockchain to solve three major problems: registration of drones, real time communication, and geofencing and traffic control. On the other hand, artificial intelligence is also being looked upon as a way to help drones to overcome the human limitations. At present, if you look at it, most of the drones are controlled by humans to a large extent, but the AI controlled drones are looked upon as a future where AI would take most of the decisions. This is just one instance on how AI can impact the future of drones. It can be impacted in every aspect, such as data gathering, data analysis, decision making, etc. Another area of impact is urban air mobility, a concept which is completely going to revolutionize the way we commute today. Companies like Uber and Airbus, they're all collaborating with NASA and other such organizations to create the architecture. For instance, even NASA had signed an agreement with Uber Technologies earlier this year to explore the further options. Even for the businesses that use Internet of Things, the location data, it's an exciting time for them as the applications are going beyond the drone's delivery services. The ability to capture, process, and make sense of geographic information will impact a lot of industries. Now, Let's talk about it where the industry stakeholders are showing their interest. Drone as the tool is gradually becoming a primary source of data collection. However, the collected data is meaningless if it is not converted into insightful results. But thanks to the technologies like data analytics, the collected data can now be converted into actionable insights. To give you in context, the acquisition of a data analytics provider Redbird by drone service provider Airware way back in 2016 shows that the roots of this trend is go way back in time. Now, I cannot emphasize enough that the drone delivery is another major avenue that will solve real life problems. The usage of drones for parcel delivery is currently very limited owing to the factors such as absence of traffic management system, improper regulations, lack of trust on current technologies, etc. However, thanks to the ongoing efforts by FAA and NASA, the condition is changing and it is changing very quickly. The third shift in the industry is currently is observing that is from hardware to software. To give you an example, in 2016, a drone manufacturer in the US named 3D Robotics completely shut down its drone manufacturing business and became a drone service provider. Another shift is UTM system that is going to be expected to be a centralized system which will involve a lot of stakeholders. At present, a series of companies ranging from drone service providers to retail giants to communication companies, they're all collaborating with NASA in order to create an architecture of UTM. Now, let us have a look at the five major components that PI's research had identified as major focus areas where commercial UAV industry is looking at. If we call drone as a robot with wings, then cameras are definitely our eyes in the sky. The unprecedented rise in demand of drones for applications like photography and commercial filmmaking has resulted in a clear shift in the market from a standard definition camera to the high definition ones. To talk about LiDAR, then before the advent of drones, they were largely limited to collection of aerial data through airplanes. It was a costly affair and involved a lot of human intervention. But since the advent of drones, the LiDARs are now being used in surveying of historical sites, agricultural lands to gauge the weather changes, and all of this is being done at less cost and more efficiently. Now, if you talk about sense and avoid system, and you are someone who belongs from regulation or regulatory authorities, you don't want to wake up with the news of a flying drone colliding with a manned aircraft and claiming lives. But thanks to the sense and avoid systems and the developments in this area, we have this fear diminishing day by day. For the successful implementation of the UTM system as well, the sense and avoid system need to be 100% perfected. If you talk about battery, then it is one of the vital part of the drones, and for the successful delivery of medicines or other parcel, the battery backup time need to increase, and that's where more of the developments are going to come in the future. Now let us talk about the geographical distribution of revenue generated in commercial drone market. North America, if you look at it, is a clearly dominant region in this sector. Players from across the value chain, be it component supplier or manufacturer or software provider, they're all present in the region. Interestingly, the leading drone manufacturer DJI, which has headquartered in China, acquired 65% nearly market share in commercial drone industry, considers North America as the region contributing the major share in its revenue. Asia Pacific is just next in the line. The declining cost of drones is one of the prime reasons behind their wide acceptance in the price sensitive countries present in the region. Along with that, the urbanization and industrialization in the countries has exhibited a high demand of drones in the countries. Now, if you talk about Europe, then a very interesting thing about European countries is that many of them opt a very liberal approach towards the adoption of drones. In France, the beyond visual line of sight operation is allowed in many parts since 2012. And if you look at Germany, the Domino's is delivering pizzas on the sidewalks in many parts of the country. Although different laws for the usage of drones in different countries is a big challenge, and that is being tackled by European Union. Now, basis of end users, the drones are solving several real-world problems, be it increasing the yield of farmers through precision farming, efficiently detecting any leakage in oil and gas pipeline, avoiding any big accident, to creating the map of mines in the places which are inaccessible. The list goes on. But thanks to the technology, that most of these works are being done effortlessly and efficiently. I would like to invite Mr. Chris to throw some more light on the end user perspective of the drone industry.
Thank you
Over
very
to
much,
you, Mr.
Gaurav.
Chris.
So, in being asked to deliver this webinar, it was quite difficult for me to keep the delivery of the topic down to 15 minutes because I could really talk for hours about the use cases of drones and the success that we've had to date. Before we start and go into the slides, I'd like to tell you a little bit about Cyberhawk. We are a drone service provider who deliver data either through manual reports, PDF reports, but we also have a software solution called iHawk. And we've been in the business of capturing and reporting data from drones for 10 years. So when we started, there weren't a lot of companies doing this, and consequently, we to date have completed something like 25 of the world firsts of using drones. So in that, I mean the very first wind turbine inspection, the first inspection of an oil and gas flare, the first inspection of a transmission tower, and the first inspection of the underside of an oil rig, first inspection of a cargo oil tank on a tanker. So there are many varied use cases, but I really wanted to, due to the time limitations, is talk about the one where perhaps we've had the most success. And I think a lot of people like to measure success in terms of the biggest savings. So I focused the presentation today on our vertical where we generate the most amount of income for our company, and that's for the oil and gas industry. So if we can go to the next slide, please. So in the picture, you can see a flare stack. In this case, these flares in the foreground are actually in the Middle East. High radiant heat, and I think it's an obvious use case because you really cannot send a person to inspect these assets when they're live. So quite often this is the first type of asset we get asked to inspect by an oil and gas company. Historically, in the past, in my career in the oil and gas industry, where I spent 20 years working as an inspection engineer, the facility would have had to have been shut down, closed. The process would have been taken offline, and then I would have put on specialist climbing equipment. I would have made my way to the top of the flare stack, and I would have carried out my inspection of that asset, taken photographs and made a detailed written report, but I would have had to have gone up there. What we're doing now, if we can go to the next slide, please, is capture the inspection whilst the asset is live. The plant does not have to be shut down. And the savings for the oil companies, if you don't have to shut down a chemical plant or an oil and gas refinery, are huge. The first example that I present here is of a refinery that we inspected in 2012. And the oil company rang us up and said, we have seen a flame coming from a part of the flare that we shouldn't see a flame at all. It shouldn't be burning 4 meters from the top, but we're certain we've seen flames there. And if you can't mobilize a team today, we're going to shut down the refinery. And the cost of shutting down that refinery is a cost of about £1.5 million a day, roughly $2 million a day. So we went to the facility, and very quickly we were let on site, and we flew the drone, and we were able to see that, and you can see it on the screen here, that in the shoulder of the molecular seal, which is the vessel directly underneath the flare tip, which prevents burn back, so it prevents gases returning down into the structure, there'd been a perforation. So a low wall thickness reading had been found on the shoulder of the asset a few years past, and the thickness of the steel had become too thin, and consequently during a blowdown the gases were able to perforate and punch a hole in the shoulder of the molecular seal, and then it caught light. So we were able to measure the size of the hole in the molecular seal, and we were able to monitor it every day for a week. They didn't shut down the facility, and they said, okay, we'll plan the shutdown effectively, we'll plan it next month, but meantime we'll get some advice from our engineering team. And what actually happened was that there was no unplanned shutdown. They were able to maintain the inspection. We inspected it every month. We were able to prove that the hole was not getting any larger, and consequently the refinery saved over £50 million in not having to shut down that asset. At the time we said to the refinery, well look, we don't want to get paid a day rate, you can just give us a percentage of the savings. We just want 5% of the money you've saved, but they elected not to pay us that, and we just got the day rate. So if we look at the next example, also focused around flares. If you go to the next slide, please. Here we have a flare that is in the North Sea, and what we can see is a circumferential crack around the flare tip, and we can see a lifting pad that is coming off the flare tip. Now what you're not able to see in this image is that this is 125 meters off the deck, and the flare tip overhangs the structure of the platform, and should this piece of metal fall onto the platform below, it would definitely have catastrophic results for the plant if it fell on a piece of pipework or a valve, but similarly if it fell on somebody's head, it would kill them. So we monitor this defect, we measure it, we send a team out there every month, and the oil company is then able to verify that the crack is not getting any larger, they're in control of the defect, and no need to shut down the asset. So all the time we're trying to save the facility from being shut down. If you go to the next one, please. Another example, these are all big numbers. This time we did a flare inspection in Nigeria, and we inspected 5 flares in less than a week while the plant was completely operational. They didn't believe that they had any issues with the flare tips, and we found that 3 of them were severely damaged, and they ended up ordering new flare tips on the advice of our findings. And one of the limiting factors with the design and manufacture of flare tips is that if you wanted to order a flare tip today, it would typically take you more than a year to receive that new flare tip. They don't keep them in stock. They're made of exotic stainless steel materials, and they're made to order. And if an oil company wants to buy one at short notice, then they get paid an awful lot of, they get charged an awful lot of money for the short turnaround of that. Some facilities keep spares, but in this case, this facility in Nigeria did not have spares. And so they were able to order their replacement flare tips in time. They didn't have to shut down the asset to do the inspection, and their figures in terms of savings were $11 million savings to the client. So all the time when people ask us how much money we're saving, it tends to be in the millions of pounds. Next slide, please. Another use case that very familiar to me and close to my heart is doing underdeck inspections. In this case, the underside of an oil and gas platform offshore, very difficult to access. When I was working offshore, I would wear a safety harness, roping, caving equipment, and I would abseil underneath the platform, and then I would use wire slings, pass them through the structural steel, and then I would maneuver underneath the deck. Quite dangerous and very difficult to do. If you go to the next slide. And it takes a lot of time to maneuver to get yourself in position. The slides on the right hand side show you that there's a series of structural steel and closed drain pipe work, and this all has to be inspected, looking for leaks or potential areas of corrosion that might allow product to leak into the sea. For this particular platform, we were able to carry out the underdeck inspection in 3 days. It was done previous to this by a 6-man rope access team, and it took them over 14 weeks to do the same type of inspection that we've just done in 3 days. So saving the client over £1 million. Next slide, please. At the same time that we can do the underdeck inspection, we try and inspect all of the difficult, cumbersome places that there are to do inspection offshore. So we'll fly down, right down to the water level, and we'll inspect the jacket legs, which is the structure which holds the platform up. We'll inspect the risers and the caissons, which are the pipes that bring the oil and gas up from the seabed, all without the need for anybody to put themselves in harm's way. And if you go to the next slide, and we recently did an inspection campaign offshore where we did 64 platforms in 6 weeks. All done, the inspection was done from the back of a boat. Much faster, tangible results, so 100% access to all areas with imagery to back up those findings. And another way that the drones can really be used to save time and money. Okay, next slide, please. One of the most recent world first that we did was the internal inspection of a cargo oil tank. And as I speak, we have a team in Singapore carrying out the internal inspection of a cargo oil tanker. We fly around all the structural components within the tank, and we get close-up visual inspection of those areas. And because of our knowledge of the defects within those tanks and our inspection background, we're able to classify and describe the findings within those tanks and do it completely remotely. Just to give you an idea, the saving for staging, so this oil company, if we weren't able to do it with a drone, would have used staging or scaffold, and for the tanker alone, it was $1 million saving for just the scaffolding. And next slide, please. Here you can see the drone in the foreground. You can see we use a number of different drones. In this case, you see the Falcon 8, but we also use the Flyability Helios. We fit lights to the drone and we fly to those, as you can see, it's flying near a bulkhead there, sort of a wall within the tank, and we're inspecting the web and the flange of the structural steel. A 75% reduction in working at height. It took us 1 to 2 days per tank. And of course, nobody needing to climb or work at height. I must say that at the moment, we are still required to go into the tank. We are in there flying with the drone, watching it, because the sensor and avoid systems aren't reliable enough. But it's still a far cheaper and safer way of doing it than using rope access or scaffold. And next slide. So when we carry out inspections, one of the tools that we always carry with the drone is a thermal camera, infrared. If you go to the next slide, you'll see that we can use a camera to determine hotspots. This is a radiometric camera, which means that every pixel on the camera can give you a responding temperature reading. What you must do first of all for it to be accurate and valid is you need to test the emissivity, so you need to know the values. So test the camera on the ground with a similar material so that your corresponding temperature range is reflective of what you find when you fly. And in this case, what we're able to find on this ducting in a refinery is that some of the panels of the insulation had fallen off. In this case, they're indicated with a slightly yellowing color scheme. And that means that the internal refractory on the inside had fallen off. So the refinery owner is able to order materials ahead of time before the shutdown, before the turnaround, and be prepared. Next slide, please. Okay, well that kind of brings us very neatly to the end of my section, and Gaurav, back to you.
Thank you so much, Chris, for sharing all those case studies, the live case studies, and Mr. Gaurav for defining drones and how their capabilities can be leveraged in commercial business operations. What we understand, definitely drones are not just a fad. They are here to stay and soon will become a mainstream. And I believe that the $12 billion market opportunity that we at BS Research forecast, drone industry is just touching the tip of the iceberg in terms of new ways of conducting business. And we see drones headed for new heights in the business, and rightly pointed by Chris that the world is full of economic potential and is likely to be multiple times that number. With that thought, ladies and gentlemen, let me conclude today's session. And I now declare the forum open for any questions from the listeners. You may type in your questions on the right side of the screen, and we'll be happy to answer any questions today over the phone. Chris, we have a question from Matthew Desai. Hi, Chris, can you tell us which drone was used by Cyberhawk for these use cases?
Yeah, sure. I'd say for the majority of our missions, we use the Falcon 8, which was originally manufactured by Ascending Technologies, and they were subsequently bought by Intel. We describe that as our workhorse. We do 90% of our flying with that, and we have more than 30,000 flights with that drone. And the other one we use for confined spaces is the Flyability Helios, which is the kind of drone that's shrouded in a ball, if you've seen that. So those are our two drones that we use the most.
Great. Chris, we have got one more question for you. The question is, there has been an unprecedented demand for drones coming from the construction industry. How do you think companies dealing in construction business can benefit from the drone technology?
There is a huge drive for the use of drones for construction, and we actually have a software solution which is being used by one of the oil companies for the construction of a chemical plant. And the way it's used is that if you gather data regularly, then you can share one source of truth, so you can see the true build of the plant or the construction over time, and you have a record of what happens at particular intervals. It can be used for, and you obviously don't have to put people in harm's way. You can fly the drone. In this case, it's being done once a week. You get the team capturing the data is building a 3D model of the asset. They're using it for project deconfliction. So by gathering the aerial data, you can see who's working on what parts of the plant, and you can stop conflicts before they arise. But it's all about the sharing of the data. If you don't have a mechanism for sharing the data, then it's not so useful. So it's important that companies considering this think about, how am I going to share the information with everybody in the team so they've got the same information.
Thank you, Chris. There's one question that I would like to direct to Gaurav. How do you foresee the air traffic management once you have situations in which swarms of drones, flying taxis, and commercial airplanes would share the same airspace? This question has come from Mr. Jensen Dugast.
Hi Jensen, thanks for asking this question. It's basically one of the most prominent questions which a lot of people are asking about, and they're very much worried about. So I would like to address it this way, that since it's a concern coming from public as well as regulatory authorities. However, Jensen, if you look at NASA and FAA, the model of UTM and the architecture that they are working on, they have almost near perfect solution for preventing any such situation from arising. If you look at the height, that is limited up to 500 feet. So it completely rules out the possibility of a drone colliding with a commercial aircraft as long as it's not in the proximity of an airport. And for air taxis and swarm of drones, the flight plan needs to be filled beforehand in the UTM system, how they're planning it to be. So it will not be approved if more than one of these are applied for the same path at the same time. So there are definitely other loopholes, there are definitely other problems in the whole system. However, UTM concept, to become it a reality, the governing bodies like NASA, they're collaborating with other companies, they're also working with other organizations, and that's how they're trying to eliminate such kind of roadblocks and ensuring the safe and secure implementation of the UTM system, which I believe will definitely tackle with any such problems if it arises in future.
Thank you, Gaurav. We are already running out of time, but there's one last question that I would like to direct to Chris. It is from Mr. Paul. What advancements do you think will be required in the drone ecosystem to make beyond visual line of sight operations a reality in the future?
Good question. It definitely has to be around the deconfliction of aircraft, and the regulatory authorities won't allow it until we can have a sensible, safe sense and avoid system on drones that don't require human input. And that really is what's missing from the ecosystem right now. We know the technology can fly beyond visual line of sight. That's already been done. It's been done for years. But how do we do it safely? And I think until there's a way of deconflicting aircraft, then we won't be allowed to do it legally.
Great. Thank you so much, Chris, once again for being the guest speaker for today's webinar. I really appreciate your patience and time for this event. And thank you, Gaurav, for all your wonderful insights. And to all the attendees, really thankful to you for you attending this particular webinar. We'll be looking forward for your feedback so that we can try and improve our webinar in the forthcoming editions. Once again, have a nice evening ahead. And thank you so much once again for participation. Have a nice day ahead.
Thanks, everyone.
Thank you, Chris.
Thank you, Chris.